Okay, this is what we're going to do today is hexadecimal to binary. Some of you, if you miss the first presentation, slide 1 through, I think it was 1 through 4, you need to go and look at it before you can start this section. It will make more sense to you. So we are starting because we did decimal that we use every day to binary, and we took from binary back to hexadecimal. And some are probably wondering, why do we need hexadecimal? Hexadecimal, by the way, is base 16. Numbers between 0 and 9. Whereas binary is base 2, which is 0 and 1. So you probably say, why do we need hexadecimal? Well, I prove to you now that hexadecimal is our friend. Without hexadecimal, we cannot do anything. It will be difficult to do. So just to review what we did the last time, we know that when we have a number, very small number like this, in binary, we can take it to decimal, base 10. Okay, and we said it's very easy. We line up all the numbers and we plug in the powers of 2's. 1, 2, 4, 8. So in this case, this is very easy. It will be 8 plus 2 plus 1, which is 11. So this is very easy to do. Yeah, but suppose we have a big number like this. In binary, how do we take it to anything? Some of you don't really get it yet. Let me give you what this means. This is a very big number. Okay, if you have to plug in the powers of 2's, it will be too big. For example, this will be 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048. You see, we are not even halfway yet, so this doesn't make any sense. So hexadecimal is our friend. Hexadecimal said, well, it's very easy. I'll just let you group them into group of 4's, going from right to left into group of 4's, to group of 4's, So we're going to prove why group of 4's in a minute. Sometimes it doesn't divide evenly. In this case, it does. It could do anything, we should be able to handle it. Why group of 4's? If we see our powers of 2's, 2 raised to 0, 2 raised to 2, 2 raised to 3, 2 raised to, 1, 2, 2 raised to 3. 0, 1, 2, 3. This is 8, 4, 2, 1. Okay? Hexadecimal is number between 0 and 15. Excuse me, I changed this to 15. Number between 0 to 15. And the first 4 bits will give us combination between 0 to 15. So in slide 2, we need to prove that. I want everybody to see that the first 4 slides, the first 4 bits will give us number between 0 to 15. Let's prove that. Okay? Remember, we have 8, 4, 2, 1. I want everybody to be able to do this. Suppose I have 1, 0, 0, 0. What does this mean? It means 8 is there, 4 is not there, 2 is not there, 1 is not there, so that means 8. Suppose I have 1, 0, 1, 0. It means 8 is there, 2 is there, which is 10. 1, 1, 0, 0. 8 plus 4, 12. 1, 1, 1, 0. 14. 1, 1, 1, 1. 15. 0, 0, 0, 0, 0. So this first 4 bits has given us what we know that hexadecimal number between 0 and 15. So I'll bring back the big number I gave you before. I'm going to write it down again from slide 1. I gave you 1101. We group into 1011, 1100, 1011, 0111, 0111. You see, this is the number. Let me check again. 1101, 1011, 1100, 1011, 0111. Okay, this is the original number I gave you that we are trying to take to hexadecimal. Okay, so what we need now is to plug in the powers of 2's. I plug in your 8421 that we did, 8421, 8421 on top of them, 8421, 8421, 8421, 8421. Okay, so if you look at this, this means 7, 7. This means 11. This means 12. This means 11 again, and this means 13. Okay, but if you write them together, we would know the difference between 11 and 1, 1 and 12, 1, 3, or 13. So hexadecimal came up with something very fast. Look at our decimal and hexadecimal. 0 is 0, 1 is 1, 2 is 2, up to 9. Okay, let me start on this side again. As soon as decimal turns into 10, hexadecimal is A, 11 is B, 12 is C, 13 is D, 14 is E, 15 is F. Okay, so in this case, 11 now, we will not be using 11 anymore. We'll be using B. We'll not be using 12 anymore. We'll be using C. We'll not be 11 again, which is B. We'll not be using 13. 13 becomes D. So these numbers now that we did, let me get a bigger room to write it. This number now becomes D, B like in boy, C, B like in boy, 7, 7. D, B, C, B, 7, 7. It looks pretty crazy, but it's very powerful. You're going to see. Okay, so let's go to slide 3 now. This is slide 2. Let's go to slide 3 very briefly. Slide number 3. From slide 2 we got D, B, C, B, 7, 7. Okay, this is now hexadecimal base 16. But some of you don't believe it. So let's take it back to where we came from, binary base 2. Okay, so remember we use 8421 to group them, so we're going to use 8421 again to separate them. So each of these now, I'm going to be using 8421, 8421, 8421, 8421, 8421, 8421. Okay, let's start with 7. With 7, I only need 421. 7 again, 0, 1, 1, 1. B is 11. I need 8. I don't need 4. I need 2 and 1. C is 12. I need 1, 1, 0, 0. B is 11, 1, 1, 1, 0, 1, 1. And D is 13, 1, 1, 0, 1. So I'm going to write them together now. 1, 1101, 1011, 1100, 1011, 0111, 0111. You see that this is exactly what we started with in slide 1. So I'm going to put slide 1 there for you to see. You see that's exactly what we have. We have 1101, 1101, 1011, 1100. Well, let me group them so we can see. 1101, 1011, 1100, 1011, 0111, 0111. So it works out here well. So your magic number is, now we have it in binary. So your magic number is 8421. And we have many applications of this. Okay, so just to see how much we use this hexadecimal, I'll let you go back to your computer. Those of you who have a computer in front of you, go to the command on your PC, go to your command prompt. Command prompt. You will see a blinking line. Type in ipconfig/all. If you are using Linux, so type ifconfig. You see there is something called the MAC address. In IP4, let's take it to IP4. Becomes complicated in IP or the IP6. Okay, MAC address is a 48-bit. We use it to recognize, like your shadow, when you send information from your PC in your little room all over the wall. Your MAC address, like your shadow, follows you around everywhere that you go. It's a 48-bit. If you look at it, so let me go to slide 4 now and break down the MAC address for you a little bit. So the MAC address now, this is slide number 4. MAC address is 48 bits. So it's like in these so many groups. 1, 2, 3, 4, 5, 6. They are all 8 bits each. 8 times 6, 48. And it's going to look like what we just did. Okay, it will look like DB. I'm reading what we did before. DB CB 77 plus more stuff. So you can break them down to 8 bits. So we use hexadecimal every day. So now you can see that we can take from binary, that we use the computer language, to hexadecimal. And when you program and you are rotating triangle in your graphics program, you are using hexadecimal. You are doing all kinds of stuff for your graphics, rotation, transformation, scaling, all those things when you are doing those matrices. So we use it quite a bit.